Ever pondered how a tiny particle can redefine technological advancement? Welcome to the fascinating world of quantum dots. Quantum dots, or QDs for short, are no ordinary particles. These are semiconductor nanocrystals with dimensions mere nanometers in size. Picture a particle so small that 1 billion of them could fit on the tip of a needle. What makes them extraordinary, however, is not their size, but their unique optical and electronic properties, a result of quantum mechanical effects. Quantum dots are at the heart of nanotechnology and materials science. When these tiny particles are illuminated by UV light, something magical happens. An electron within the quantum dot gets excited to a state of higher energy. In terms of semiconducting quantum dots, this would correspond to the electron transitioning from the valence band, a band of energy levels filled with electrons, to the conductance band, a higher energy level band. Now, this excited electron doesn't stay in the conductance band forever. It eventually drops back into the valence band, but in doing so, it releases its energy in the form of light. This phenomenon is known as photoluminescence. The color of this light varies and depends on the energy difference between the conductance band and the valence band. In a way, quantum dots behave like tiny disciplined soldiers, confining either electrons or electron holes within their nanoscale semiconductor materials. This confinement is similar to the model of a three-dimensional particle in a box. The absorption and emission features of quantum dots correspond to transitions between discrete quantum mechanically allowed energy levels within this box. These energy levels are reminiscent of atomic spectra, earning quantum dots the nickname artificial atoms. These artificial atoms, as we've seen, have bound and discrete electronic states, much like naturally occurring atoms or molecules. However, they also possess properties intermediate between bulk semiconductors and discrete atoms or molecules. Their optoelectronic properties change with their size and shape, making them incredibly unique. Quantum dots, being artificial atoms, exhibit an incredible light show, but that's just the tip of the iceberg. Size in the realm of quantum dots dictates color and function. When we delve into the microscopic world of quantum dots, we find a fascinating phenomenon. The size of these nanocrystals directly influences their optical properties, essentially determining the color they emit when illuminated. Picture this: larger quantum dots, those around 5 to 6 nanometers in diameter, emit longer wavelengths. This results in the warm hues of orange and red. On the other hand, smaller quantum dots, about 2 to 3 nanometers in size, emit shorter wavelengths, which translate into cooler colors like blue and green. This variation in color is not arbitrary, but a direct consequence of the energy difference between the conductance band and the valence band in these nanocrystals. So, the next time you marvel at a spectrum of colors, remember, it's not just about the light, it's about the size too. Indeed, in the case of quantum dots, size does determine the color spectacle. Quantum dots are not just solo performers, they can also create a symphony together. When 2 or more quantum dots are coupled, they form what we call an artificial molecule. This is an intriguing phenomenon that allows for hybridization, even at room temperature. Now, imagine a meticulous assembly of these quantum dots. They can arrange themselves to form what scientists refer to as superlattices. These superlattices act as artificial solid-state materials. But what does this mean? Well, they have unique optical and electronic properties, unlike anything we see in naturally occurring substances. This is all thanks to the magic of quantum dots, these tiny particles that are constantly redefining what we understand about the world of nanotechnology. So, quantum dots can play together to form more complex structures, opening up a realm of possibilities. The stage is set, and the quantum dots are ready to perform their next act in this grand play of science. Quantum dots are not just a scientific marvel, they are a catalyst for technological innovation. These minuscule particles, brimming with potential, are set to revolutionize a multitude of fields. Imagine a world where our electronic devices are powered by single electron transistors, made possible by quantum dots. These transistors, far smaller and more energy efficient than their traditional counterparts, could drastically shrink the size of our devices while also increasing their power. Solar cells, too, stand to benefit from these tiny titans. Quantum dots can be tuned to absorb different wavelengths of light, making solar cells more efficient and effective at harnessing the sun's energy. In the realm of lighting, quantum dots are already making waves. They're employed in LEDs to produce vibrant, pure colors that were previously unachievable. And lasers? Quantum dots can be engineered to emit light at specific wavelengths, paving the way for lasers with unprecedented precision. Quantum dots may even play a pivotal role in the development of quantum computing, a field that promises to dwarf the processing power of today's computers. But the implications of quantum dots extend beyond electronics and into the biosciences. In cell biology research, quantum dots can be used as fluorescent markers, illuminating the inner workings of cells like never before. This could revolutionize our understanding of cellular processes and disease mechanisms. In the field of medical imaging, quantum dots offer a potentially safer and more effective alternative to traditional dyes. This could lead to clearer, more precise imaging and earlier detection of diseases. What's more, the small size of quantum dots allows them to be suspended in solution. This opens up a world of possibilities, including their use in inkjet printing and spin coating, leading to less expensive and less time-consuming methods of semiconductor fabrication. Quantum dots, then, are not just tiny particles, they are titans of technological advancement. They hold the promise of a future where our electronic devices are more powerful, our energy sources more efficient, and our understanding of the world around us and within us is profoundly deepened. Quantum dots, the tiny titans, are indeed a quantum leap in technology. These nanoscale semiconductors, with their unique properties, have blurred the lines between science fiction and reality. Their ability to emit a spectrum of colors based on their size and shape opens up a world of possibilities. From single electron transistors, solar cells and LEDs, to medical imaging and even quantum computing, the potential applications are staggering. The future is here, and it's lit up by quantum dots.